Pump selection. How do we pick the best pump? Well, we need to have a pump curve. And so we put together ourselves a scenario that we have calculated a gallons per minute demand. That's something we have to know. We know we're going to run so many sprinklers at so many gallons a minute per sprinkler, therefore it's going to cost so many total gallons per minute. We pick that. That's a given that we give it. If we're going out here and run the golf course and we're going to run 4 sprinklers at a time and they all run at 40 gallons a minute, we know we need 160 gallons a minute on a continuum. And those sprinklers will be turning off and others will be turning on, but they'll be continuously cycling over the night, and we'll have 4 of them running all the time, and we need 160 gallons a minute continuous for the duration of the cycle. If we have a wheel line out here that's 30 pipes long, every head has a 5 gallon a minute nozzle on it with a flow control nozzle, so they're all running 5 gallons a minute. We know we have 30 times 5, that's 150 gallons a minute. It's going to run, that pump needs to run 150 gallons a minute, continuous. So we give that GPM, we spec that. Now we calculate also the pressure that it takes, you know, the TDH, addition of the exit pressure, plus the friction loss, plus or minus the elevation, plus the velocity head. Those 4 things then will add up to give us our TDH calculation. Then we simply divide it by this, and then the efficiency of the pump that we have to look up on the chart. Now you all have a pump curve in your packet. So let's take a look at that pump curve. This happens to be from Cornell Pump. They manufacture in Portland, Oregon. They've always been real good to our program, so we'll promote them just a minute. They have excellent pump curves, so it's a great one to evaluate. On this particular curve, it tells us all the things we need to know. First thing is flow. Well, here's the flow. Down here along the bottom, they call it capacity in US gallons per minute. Not cubic meters per second, not Canadian gallons per minute, not cubic meters per second. This is US gallons per minute. We need to be able to find pressure. Well, pressure is the total head on the y-axis, the vertical axis. Total head in feet. It tells you the units are in feet. And this one goes from 0 to 200 feet. Actually goes up to 225. It goes just over 200 feet on the maximum possible pressure built by this pump. Now horsepower. Horsepower is shown internally in the curves, and you can see there are the diagonal hash lines going from upper left to lower right across the face of the chart. And those diagonal lines give you the different horsepower ratings. Now see, the horsepower is going to vary according to pressure and flow. We could put all kinds of different motors on this particular pump. Now when we talk about pump, we're just talking about the volute. And then we put a motor on the end of that volute. The pump end. We're talking about the pump end. And we put different motors on it according to the load that we're putting on it. Yes?
The total head, the like 13.5 diameter, is that the intake side or is that the...
Okay, a good point. And that's something you need to add on your notes there, is the diameter of the impeller.
Okay.
We can change the diameter of that impeller. This impeller, you can really see how the veins are inside of a pump. They have multiple veins that the liquid gets caught up in, and then the water comes in the center, and this thing rotates in this direction, and the water comes in the center and gets slung out the sides here. This was a product pump. This pumped peas in a food processing plant. And it was big enough so that peas could move through the passageways, so it's pretty wide. But we can make this diameter bigger or smaller. You know, this might have had a 8-inch diameter impeller on it to start with, and they made it smaller simply by putting it in a lathe and turning it down, reducing the diameter of the impeller. So that's why it notes here all these different diameters. It goes anywhere from 13.5-inch diameter all the way down to 10-inch diameter. That's the smallest that they'll make it. It comes as a 13.5-inch diameter impeller for that particular pump, and then they simply put it on a lathe and turn it down if they want it smaller to fit the condition that we're after. So we can pick a condition and make some decisions about it.